Limitations of the single diode rectifier. A single diode rectifier is a very simple type of AC-DC converter. It is only able to supply power from the AC source to the DC load when the input voltage is positive. But when the input voltage is negative, no power is transferred from the source to the load, even though the input is able to provide power during this stage. In other words, only half of the AC waveform is rectified to DC, and the other half is essentially ignored. Also, if we want to maintain a relatively constant output voltage, we need a relatively large output capacitor. If we want to improve this converter, we should think of a way to draw power when the input voltage is both positive and negative. As we saw from the single diode rectifier AC-DC converter, power is only drawn from the input when the input voltage is positive. To increase power utilization, we may want to draw power during both positive and negative stages. To achieve this, we use a slightly more complicated circuit topology that utilizes 4 diodes. This 4-diode rectifier is very commonly used when going from AC input to a DC load. Let's take a look at how this operates. Here we're going to look at a 4-diode rectifier. This is going from an AC input to a DC output. And we're going to use 4 diodes to help rectify this AC signal into a DC signal. So here's our setup as shown here. We have our 4 diodes and our load is a resistor and it has this polarity. And we're going to break it down into 2 stages again. First, we're going to look at when we have positive voltage on the input. So here we have our AC wave, we have positive voltage here, and that means our polarity in our input is going to look like this. And we want the current to flow from the input to the output through these diodes. But we have so many diodes, where does the current flow? We want current to flow through the resistor this way because we want positive voltage on the output. So if you see, we have to go through diode number 2 in order to flow in that direction. Through diode 2, through this resistor, and then back towards the input to complete the circuit. In order to get from this point to the input, we have to go through diode 3 here in order to complete our circuit. So you can see the current path here. What this means is that if current is flowing, our polarity has to be forward biased. So here we need positive, negative voltage, which we see from our input, we would be getting that voltage over our resistor and then all the way through to our diode number 3. So here you can see the current flowing through our system here. On the output, this means that the output would simply look just like the input here. So actually go all the way down to here and look exactly like our input. Now let's look at the negative voltage phase. So when the voltage is negative, so here we'll draw the first cycle here. We have negative voltage here. Our polarity is reversed at our input. The thing is that we want our voltage has to be negative, but we want our current through our diode through our resistor to be the same. So here our current needs to flow this way. So let's trace a path from our input through our load and back around. So we start here, we go through here, we get to this fork in the road, and we want to go from this point to our load. So we actually have to go through diode number 4 in order to flow in that direction. We go through the resistor and then back out through this path. And in order to complete the circuit, we see we have to go through diode number 1 to complete this current circuit. In order for that to happen, for current to flow through these diodes, we need to make sure the polarity is correct. So we see positive, this diode will have to be positive negative in order to flow in this direction, and this one will have to be in this direction in order for this current to flow. Again, we get on the output, we get positive and negative here, and so everything is positive on the output here. So during this phase, we can see if we draw from the output, it will follow the opposite of the input voltage here. So if we look at the final product of this system, we have our AC wave coming in here, so positive and negative, and all the negative parts here will be flipped and become positive on the output, which you can see here. So this is the 4-diode rectifier. This is also generally called a full bridge rectifier, because full wave rectifier, because we are rectifying the negative parts and making them all positive. Another way you can think about this is taking the absolute value of the input voltage, and your output voltage is the absolute value of that waveform. So this is the basic operation for a 4-diode rectifier. Next, we'll talk about the 4-diode and capacitor rectifier. All we're doing here is adding a capacitor. Here you can see the capacitor here at the output. And this, we're going to use this in order to maintain the output voltage at a higher voltage. So let's go through the stages of this again. Here we're going to have 4 stages of operation. So we'll start with positive voltage. Our voltage is going to be positive up to about here. And this will operate the same way as it did before. We're going to have positive, negative voltage bias here. Our output will also be positive, negative here. And we'll have current flow through diode 2, through the resistor, and also through the capacitor here. Then when it comes back around, in order to complete the circuit, it has to flow through diode number 3 in order to go back to the input. So during this part, voltage over the diodes is biased like so, and current is flowing through our system like this. Because of the capacitor, we're going to have a slight change once the voltage of the input becomes lower than that of the capacitor. Once that happens, we're going to have no power, no current through the diodes, and actually all of the power through the resistor is going to come from this capacitor. So in this last stage, we charged up the capacitor, and in this stage, that power is going to go through our resistor here and charge up and provide power to our load. So here you can see this would be this region. Here, where it's kind of flat, starts to decrease slowly. That's this region where the capacitor is providing power to the resistor rather than power through the diodes. And that region is essentially shown here on the input, and you can see it here at the output. Okay, let's look at the next phase. The next phase is going to be, we're going to look at the negative polarity. Here our input voltage is reversed, so shown here. We're going to be looking at this small region here, and our capacitor still has some voltage on it. But our input voltage, this voltage, the magnitude of our input voltage, is actually going to be higher than our capacitor voltage, and so current is going to flow through the diodes, and the power from the input will charge up the capacitor and provide power to the resistor. So here our current flow is going to flow very similar to the 4-diode rectifier. This time the power is going to go both through the capacitor and through the resistor, as shown here. And then in order to complete the circuit, it goes through diode 1 to complete the circuit. So you can see the current flows all through here. This region, if we look at our output, is just right here where our input is charging up our output and providing power directly to the load. The very last stage is when the voltage of the output capacitor becomes higher than that of the input voltage magnitude. So this region is shown here on our input. And because this output voltage is higher than the magnitude of the input voltage, no power will flow through the diodes. They'll all be turned off. And the only power that goes through the resistor is provided by the capacitor here. And this region will be shown here on the output voltage. So here you can see the full circuit. When we have our AC input, as we see here, we have 4 different stages. The basics of this circuit is that the 4 diodes, so these 4 diodes here, flip the bias. So regardless of positive or negative or positive here, power will be delivered to this output voltage. It's the same polarity. The capacitor serves to keep the voltage high so that the voltage doesn't drop too much on the output. So you can see the voltage is maintained relatively constant due to the capacitor here. So here's our basic circuit for the full 4-diode and capacitor rectifier. This can also be called the full bridge rectifier, where we're utilizing a capacitor, and these are very commonly used in real applications. We covered the 4-diode rectifier AC to DC converter, which uses 4 diodes in a unique configuration to change AC input power into DC output power. An output capacitor can be used to make the voltage more steady. This 4-diode rectifier is also called a full wave rectifier. It draws power from the source during both the positive and negative portions of the input voltage waveform. This AC-DC converter topology is relatively simple and is used in many wall-powered devices, such as a laptop charger.